Right now, inside your brain, there's a molecule screaming for help. It's been trying to send you a message all day. Hey, you're exhausted. Please slow down. But it can't get through. Something is covering its mouth, holding it down, muffling every single signal it tries to send. That something, it's the coffee you had this morning. Every time you drink caffeine, you're not getting energy. You're silencing your brain's distress signal. You're gagging the one molecule that's trying to protect you from burning out. And your brain, it knows. It's fighting back, and it's losing. But here's the part that really gets me. Researchers locked people in a lab for 49 days, total isolation, no windows, no clocks, and they discovered that a single cup of coffee in the evening reaches into your brain, grabs your internal body clock, and physically winds it back by 40 minutes. Your body is sitting there at 10 p.m., but your brain is convinced it's still 9:20. I'm a pharmacist. 9 years in, I read research papers for a living, and today I'm going to break down what caffeine is actually doing inside your head. No textbooks, no jargon, just the science told like a story. Let's go. All right, so your brain has this molecule called adenosine. Don't worry about the name. Just think of it as your brain's tiredness alarm. That's all it does. From the second you open your eyes in the morning, adenosine starts building up, slowly, like sand trickling through an hourglass. Every hour you stay awake, drip, 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 more adenosine piles up. And it has one job, just one. It finds these little docking stations in your brain, let's call them parking spots, and it pulls in. The moment it parks, it sends a signal. You've been up long enough. Slow down. Get sleepy. That heavy feeling at the end of a long day, where your eyelids feel like someone hung little dumbbells off them, that's adenosine. It's been stacking up all day, filling parking spot after parking spot, and your brain is finally waving the white flag.
Now, enter caffeine. Here's the twist that blew my mind in pharmacy school. Caffeine and adenosine look almost identical at the molecular level. If they were standing in a police lineup, you'd struggle to tell them apart. Same basic shape, same vibe. So when caffeine hits your brain and it barrels in fast, usually within 30 minutes of your first sip, it races straight to those parking spots, and because it looks so much like adenosine, the spots can't tell the difference. Caffeine slides right in, no questions asked. But here's the con. Caffeine does not send the sleepy signal. It just sits there, occupying the spot, doing absolutely nothing, like a car that's been parked at the airport since last Thanksgiving. No driver, no purpose, just taking up space and refusing to leave. Meanwhile, adenosine is still being produced. Your tiredness is still building, but your brain can't tell because every parking spot is blocked by caffeine, which is squatting there, pretending to be adenosine while doing none of the work. This is not fuel. This is a con job. Caffeine puts black tape over your check engine light. The engine is still struggling. You just can't see the warning anymore. And here's what happens when the con falls apart. After a few hours, your body starts breaking down caffeine and clearing it out. And the second caffeine leaves those parking spots, guess who's been standing in line this whole time? Adenosine. Hours and hours of it, a whole rush hour's worth that had nowhere to go. So when caffeine finally vacates, adenosine floods in all at once. Every spot fills up simultaneously, and your brain goes from, I feel amazing, to, I need to lie face down on the carpet right now, in about 20 minutes. That's the afternoon crash. It's not that your energy ran out. The mask fell off, and your brain suddenly realized it's been screaming into a pillow all day. If you remember nothing else from this video, remember this. Caffeine is not an energy drink. It's a gag order on your brain's tiredness alarm. And when that gag slips off, it hits you all at once.
Now, your brain is nobody's fool. It catches on. After a few days of regular coffee, your brain notices that its tiredness signals keep getting blocked. And it does what any stubborn, intelligent organ would do. It builds more parking spots, more adenosine receptors, basically saying, "Oh, you want to block my signals? Fine, I'll build a bigger antenna." This is why your first cup of coffee as a teenager felt like someone plugged your brain into a wall socket. Colors were brighter, music sounded better, you felt invincible. But now, your third cup on a Monday barely gets you from completely dead to technically functional. Your brain built extra infrastructure. It adapted. Pharmacists call this tolerance, and it doesn't take months. We're talking days. Now, and this is where it gets rough. Let's say one morning you decide, enough, no more coffee, I'm done. You quit cold turkey. All those extra parking spots your brain built, still there, but no caffeine to fill them. So adenosine, which never stopped being produced, floods into every single one, not just the original spots, all the bonus ones too. And suddenly, you've got a splitting headache, brain fog so thick you can't remember your own phone number. You're irritable, like if one more person talks to me, I will combust, irritable. You're exhausted, even though you slept 9 hours. That's caffeine withdrawal. And here's something most people don't know. It's not just a feeling. The American Psychiatric Association officially recognizes it as a clinical condition. They even define the diagnostic criteria, 5 of them: headache, fatigue, difficulty concentrating, depressed mood, and flu-like symptoms. 5 criteria. How many of those sound familiar to you? You're not being dramatic. Your brain literally rewired itself around a drug, and you just pulled the plug. One line to take away: your brain always adapts. You can fool it for a while, but it builds countermeasures every single time.
Okay, everything so far is interesting, but not exactly mind-blowing if you've poked around the internet. This next part, though, this is the one that made me put my coffee down and just stare at the wall for a minute. In 2015, a team at the University of Colorado published a study in one of the most respected science journals on the planet, a sister publication of Science magazine. Not a blog post, not a podcast opinion, the real deal. And what they did was insane. They locked people in a lab for 49 days, controlled everything: light, temperature, food, sleep schedule. Participants couldn't even peek at a clock. Total isolation from the outside world. 5 people, 4 conditions: dim light with a fake pill, dim light with caffeine, bright light with a fake pill, and bright light with caffeine. The caffeine dose was about 200 milligrams, roughly a double espresso, taken 3 hours before their usual bedtime. Here's what they found. Caffeine, just the caffeine, no bright light, no tricks, reached into these people's brains and shoved their internal clock backward by about 40 minutes. Imagine someone sneaking into your house while you're not looking and winding every single clock back by 40 minutes. Your alarm, your oven timer, your microwave, everything. That's what caffeine did to their circadian rhythm, the master clock that tells your body when to sleep, when to wake up, when to release hormones, when to digest food. Now, to show you how powerful that is, they also tested bright light, really bright, like standing next to a huge sunny window for 3 hours. That bright light pushed the clock back by about an hour and a half, and caffeine alone, just a cup of coffee, got almost halfway there, no light needed. So your afternoon coffee isn't just keeping you awake right now. It's sneaking into the control room of your body and quietly turning the master dial. It's telling your sleep hormones, your body temperature, your digestion, everything that nighttime arrived 40 minutes later than it actually did.
And the researchers figured out exactly how. Remember the parking spots? The adenosine receptors? They're not just in the parts of your brain that handle sleepiness. They're also wired into the gears that run your internal clock. When caffeine blocks those receptors, it jams a core piece of the timekeeping machinery inside your cells. Think of it like wedging a stick into a grandfather clock's pendulum. It still swings, but slower. Here's the wild part. The researchers proved this wasn't just a behavioral effect. They took human cells in a lab dish, bathed them in caffeine, and watched the cells' internal clocks literally slow down. More caffeine, longer clock cycles. And they pinpointed it to one specific receptor and one specific signaling pathway inside the cell. If you zoned out and just came back, here's the headline. Your evening coffee doesn't just steal tonight's sleep. It resets your body's entire schedule. Every organ, every hormone, every internal process gets the wrong memo about what time it is. All right, let me solve a mystery you've probably carried around your whole life. You know that person. Maybe it's your roommate, your partner, that one coworker. They drink espresso after dinner, sometimes right before bed, and they're snoring within 20 minutes. Meanwhile, you have a small latte at 2 p.m. and you're lying awake at midnight, staring at the ceiling, questioning everything. What is wrong with you? Nothing. Absolutely nothing. It's genetics. Your liver has what I'm going to call the caffeine janitor. Its real name is CYP1A2. Sounds like a droid from Star Wars, so let's stick with janitor. This janitor is in charge of sweeping caffeine out of your system. Some people got the fast janitor. This guy hustles. Caffeine comes in and within a couple of hours, swept out, gone. These are the people drinking espresso at 9 p.m. and sleeping like babies. Their system clears caffeine so fast it barely has time to cause problems. Other people got the slow janitor. This one takes smoke breaks, wanders off, gets distracted. Caffeine sticks around in their body for way longer. For these people, that innocent 2 p.m. coffee is essentially still half a cup sitting in their brain at midnight. No wonder they can't sleep. And it gets more personal than that. There's a second gene. Think of it as your sensitivity dial. It controls how strongly your brain reacts to caffeine in the first place. Some people have the dial cranked up to 10. Even a tiny bit of caffeine makes their heart race, gives them jitters, keeps them wired for hours. Others have the dial at 2, and they barely notice a cup. So if you're the kind of person who gets anxious, jittery, or your heart starts thumping after just 1 cup, that's not weakness. That's your genetics talking. Your sensitivity dial is turned up higher than average. And that is why blanket advice like no coffee after 2 p.m. is fine as a starting point, but it misses the real picture. Your personal cutoff depends on your janitor's speed and your dial's setting. For some people, noon is the real deadline. For others, 5 p.m. is perfectly fine. Take this away. How coffee affects you is not about discipline or willpower. It's written in your DNA.
Now, before you pour your coffee down the drain, hang on a second. A massive review from Harvard researchers published in the New England Journal of Medicine, and if you're not into science, just know that this is basically the Super Bowl of medical journals, looked at decades of research and found something reassuring. Moderate coffee drinking, around 3 to 5 cups a day, is actually linked to a lower risk of several serious diseases. Parkinson's, certain liver conditions, even some types of cancer. So coffee is not the villain here. The question was never, should I drink coffee? The question is, when should I drink it? And here's a free tip from your friendly neighborhood pharmacist. Try waiting about 90 minutes to 2 hours after you wake up before your first cup. In the morning, your body naturally produces cortisol, your built-in wake-up chemical. If you drink coffee while cortisol is already doing its thing, you're stacking caffeine on top of a signal that's already working. You get less bang for your buck, and you train your brain to depend on caffeine even earlier. Wait a bit. Let cortisol do its job first, then bring in the coffee as backup. Let's land this. Caffeine is a con artist. It doesn't give you energy. It gags your brain's tiredness alarm. Your brain fights back by building more receptors, which is why you need more and more coffee over time. And that afternoon cup, it's sneaking into your body's control room and pushing the master clock backward by 40 minutes. You now understand your daily coffee better than most people who drink it, and honestly, better than a lot of people who prescribe it. I'm a pharmacist. I read the papers so you don't have to. If you want more of these, subscribe. I'll see you in the next one.